So for lab 2, for Chem 1212K, we are looking at freezing point depression and determining molar mass through experiment after we calculate the freezing point depression. So we're going to be using two different substances, a solute and a solvent, to calculate first the freezing point and melting point of our solvent, add our solute, and then from that we can calculate the depression by knowing the freezing and melting points of the two substances. For the purpose of our lab, it's to determine the freezing point of a solvent and then determine the freezing point depression of a solution made up of the solvent, paradichlorobenzene, and the solute, naphthalene. And we'll also use molality, which we calculate, of the mixture to determine molecular weight of the solute. So, like I said, for this lab, we're using two chemicals, or two substances, paradichlorobenzene, which has a formula of C6H4Cl2, and naphthalene will be our solvent, which is C10H8. Paradichlorobenzene has a molecular weight of 147 grams per mole, and its melting point is right around 53 degrees Celsius. Naphthalene has a molar molecular weight of 128 grams per mole. So for the pre-lab, questions are some that I just answered. What is the formula of molar mass for the solvent to be used, which is paradichlorobenzene, which I just said. One is, what is the formula of molar mass for the solute, which we're using, which I also said. And then we're also supposed to draw the chemical structure. So I'm going to show chemical structure. I'll show that in a little bit. What is the normal melting and freezing point for the solvent to be used in degrees Celsius? So like I said, it's 53 degrees Celsius for paradichlorobenzene. Suppose the acid starts to freeze before you have begun collecting data. Explain what you should do to solve the problem. So freezing begins before data is recorded. The acid should be put back into the hot water bath and remelted again completely so you can accurately record your data. What is the freezing point depression constant for the solvent being used? And so paradichlorobenzene's freezing point depression constant is 7.6 degrees Celsius per mole. No. 7.10 degrees Celsius per kilogram per mole. What should happen to the temperature of a substance while the substance is melting? Why? So it should stay approximately the same, just because when substances are melting as a solid, they increase temperature until the point of the melting point, and then it kind of remains the same until it's completely melted. And it's because during this, all of the heat is being transferred into melting the substance and not increasing the temperature. And then if 10 grams of ethanol is dissolved in 100 grams of pure water, what would the boiling point and freezing point be for the solution? And I'm given the boiling point constant and the freezing point constant of water. So first I had to calculate molality, which you calculate using your moles of solute divided by your kilograms of solvent. So determine molality to be 2.17, and from that I was able to calculate the boiling point and the freezing point. And so the calculated freezing point is negative 4.04 degrees Celsius, and the boiling point is 101.11 degrees Celsius. Then for the actual lab, there's 4 parts of it. So in the first part, you're just going to be looking at the paradichlorobenzene, and you're going to weigh out approximately 6.5 grams and put that in a test tube. And once in the test tube, you put it into a hot water bath, which is right around the melting point of the substance, and then record time and temperature to see how long it takes to completely melt the substance. And you're going to record when it starts melting and when it's completely melted. Part 2, you're going to fill a beaker with ice. And once your solvent has completely melted, you are going to take the test tube out of the hot water bath and put it into your beaker of ice and time how long it takes to completely freeze. So that's just giving you the melting point and the freezing point of your solvent. And part 3 is when we're going to add our solute into it so we can create a solution. So you're going to weigh out approximately 1.5 grams of your naphthalene and pour that into the test tube of your remelted solvent, the paradichlorobenzene. You're going to remelt it after part 2, and you're going to pour that in. You're going to give it a little mix, and then you're going to put it back in the hot water bath and record time and temperature until the solution is completely melted. Then for part 4, you're going to repeat part 2 again. Once your solution has completely melted and is, a solution at this point, you're going to take it out of the hot water bath and put it back in your ice bath and record the time and temp it takes to completely freeze the solution. So we're gonna do that today, and it's important that we wear our safety glasses and our long sleeves and our pants. So I'm doing this in my kitchen, so I'll make sure I have the fan running and the window open just in case there's any fumes, just because it's part of the safety. It can be harmful in some instances if you use it incorrectly and you're not properly prepared. So we just got to make sure that we are good to go, and I think we are. So we're going to go do our lab now. While I'm waiting for the water to heat up to the point that I need to be at, I'm going to go ahead and measure out my substances. So for this lab, we're using paradichlorobenzene, which is a solvent, and naphthalene, which is our solute. And by knowing the freezing point of and melting point of paradichlorobenzene, and then calculating the freezing and melting point of the solution of both paradichlorobenzene and naphthalene, we can calculate the freezing point depression of the solution. So to get started, the first part of this lab is looking at the melting point and freezing point of paradichlorobenzene. So we're going to start with approximately 6.5 grams of paradichlorobenzene, which I'm going to measure now. I have my scale right here, and I have my little weigh boat. I'm going to go ahead and tear that out. So 6.5 grams. I'm going to get as close as there as I can. Just got this the other day. It's kind of all like in one big chunk. I'm kind of breaking it up a little bit. So paradichlorobenzene is a solid. It's a crystal. It's a white crystal looking substance. So we're going to melt this. And paradichlorobenzene has a melting point of approximately 53 degrees Celsius. So what I'm going to do is heat up my water over here to right around 50 degrees Celsius. And then submerge a test tube with the paradichlorobenzene into the hot water bath and time the amount of time that it takes to completely melt the amount of solvent that I have. So right now I'm at just over 6 grams. 6.56, that's what we're going to go with. Try to get it as like right on there at 6.5, but it's kind of hard, so I'm going to put that down at 6.58 grams of C6H4Cl2. Observations. It's white crystalline solid. It's approximately how much it is when it's a solid. So we're going to melt it and then record that. While we're waiting though, I'm going to go ahead and measure out the naphthalene that I'm going to need for the third part of this lab. And for that, I'm going to need approximately 1.5 grams. So I'm going to measure out 1.5 grams of the naphthalene, the C10H8, just while we're waiting for the rest of that water to heat up. This is also a white crystalline. It's got a strong odor to it though. and it's more of like in a flaky sheet, whereas the paradichlorobenzene is more of a it's more of a cubic structure. Right now we're at 1.3. I need 1.5. 1.55. We're gonna go with that. So our water is now at approximately 51 degrees Celsius. So we're gonna get started. Go ahead and put it in our test tube. Tighten her up. Go ahead and make sure that our substance is submerged below the water. So after about 26 minutes, it started melting at approximately 48 degrees Celsius. So I have my ice bath ready for when it comes out of the water, then I can immediately go through and put it into the ice bath. It's almost done melting. Around 54 degrees, which is to be expected. The reason why it's not changing temperature now is because it's reaching that heat of fusion, so it won't start increasing temperature again until all of the substance is completely melted. It is now completely melted. So we're going to flip this into our ice bath. So now we're going to freeze it in this ice bath right here and time it to see how long it takes to freeze. So it's freezing very quickly. It's at 48 degrees now after 2.5 minutes. And it's almost completely frozen. Now 3 minutes, it's been completely frozen. And it's sitting at 47 degrees. Now we're going to remelt this. So we've completely remelted our paradichlorobenzol, our paradichlorobenzene. Now we're going to add in our 1.57 grams of naphthalene that we weighed out earlier. So I'm just going to pull the test tube out just for a second so we can mix the naphthalene in, and then we're gonna record how long it takes to completely melt the naphthalene into the solution. Here we go. There it is. Just give it a little quick stir, I'm going to put it back in and start recording. Started melting by about 45 seconds. And it is now completely dissolved after a minute and 40 seconds. It's at 54 degrees. So now we're going to put it back into our ice, our water, or our ice to determine the freezing point of this solution. Keep my fucking thermometer ready. See? Completely melted. We started at 57 degrees. After a minute, we're at 52. After 4 minutes, we're at 32.1. And it's not completely frozen. So the solution together lowered the freezing point from 53 degrees Celsius down to about 35-ish degrees Celsius. So now that lab 2 is completed, my results showed that there was a depression in the freezing point of the solution after naphthalene was added. Just to kind of discuss a little bit what I got. So for the initial melting of paradibenzochlorine or paradichlorobenzene, it initially started at 48 degrees Celsius and was fully melted at 54.2 degrees Celsius. Did see once it reached about 54 degrees at approximately approximately 35 minutes. It stayed at 54 degrees until melting had completed at 46 minutes. So for about 11 minutes, it pretty much stayed the same. This is where it isn't gaining any heat because all of that heat is going into melting the solid. Had a bit of trouble with this one. I went to put it in to freeze for the part 2 of freezing it, and I was not prepared for how fast it was gonna freeze, so I had to re-melt it again afterwards. Adding in the naphthalene after part 2, added 1.57 grams of naphthalene to the solvent to make it a solution. And this mixture of the paradichlorobenzene and the naphthalene melted pretty quickly. So once I added the naphthalene into the test tube, it melted within a 160 seconds. So at 1 minute and 40 seconds was when it melted. Initial temperature started at 55 degrees and went down to 54 degrees. So, I mean, it probably had some to do with the heat already in the aqueous part of the solution from the paradibenzochlorine or paradichlorobenzene. And for part 4, freezing the solution. Once the solution had completely melted and become mixed together, put it back into the ice, the beaker of ice, and calculated the time and temperature at which it froze. And so it started freezing at about 48 degrees or so, and then was completely frozen at 32 degrees. So there was a pretty big difference in the freezing point of the solute or the solvent and the freezing point of the solution. Like I said, initial masses for the paradichlorobenzene was 6.58 grams, and for the naphthalene was 1.57 grams. And the freezing points that I got, the experimental freezing point of the solvent was 47 degrees. And for the experimental freezing point of the mixture was 32.1 degrees. Knowing this, you can calculate our freezing point depression, which is, how much it dropped by adding the solute into making it a solution. So I calculated that to be 14.9 degrees Celsius. Using that temperature, then you can calculate the molality of the solute by dividing the depression by the freezing point depression constant of the solvent, which is 7.10 degrees Celsius times moles per kilogram, or times kilogram per mole. And I got, for molality of the solute of naphthalene is 2.1 moles solute per kilogram solvent. Taking that, you can then calculate the moles of your unknown by multiplying the molality that I just calculated and the kilograms of solvent. So the 2.10, and then since we had 6.58 grams to start with of the paradichlorobenzene, you divide that by 1,000 to put it into kilograms. So that I got moles unknown was 0.014 moles. Then we can calculate our experimental molecular weight or molar mass by dividing the grams of the naphthalene that we put in divided by the moles of the solute that we just calculated. So 1.57 grams divided by 0.014, and from that I got 113.7 grams per mole as the molecular weight. Using that, we know that the actual molecular weight of naphthalene is calculated to be 128.2 grams per mole. So you can calculate the percent error by taking the absolute value of your experimental minus your accepted divided by your accepted times 100%. So I did that and got 11.3%. There are some explanations for why this error might have arisen. Was just it was kind of hard to tell exactly when the freezing and melting were actually like occurring and when they were completed, just because of using a pot, and it's kind of hard to see in the pot because of the glass, and it was kind of like all the light was refracting, so you couldn't see the solvent and the solution when they were in the pot or when they were in the beaker being frozen. It's kind of hard to get the thermometer to not touch the sides of the glass. I struggled with that a lot. And then I think that was it. That's just user error. Keeping everything at the right temperature, at recording everything correctly, making sure I was reading everything correctly. There's a little bit of room for error in there, so that could have been why we saw 11.3% error. That's some of the reasons why we might have seen that. This is page 1 of lab 2, where I have the purpose, any references that I used, my properties and safety table, and my pre-lab questions. Right above where I have the pre-lab written, you can see two structures drawn out. Structure on the left is paradichlorobenzene structure, and the one on the right is naphthalene structure. So this was page 1 of the research plan and experimental part of the lab. Over here on the left side, you can see everything that I had as my research plan, as my steps to follow. Over here on the right side, you can see my initial mass of paradichlorobenzene, any observations, the water, temperature initially. This was where I messed up the first time. This was my freezing or my melting of the paradichlorobenzene. As you can see, it took a long time, 46 minutes. Part C, this is 1.57 grams of the naphthalene, the C10H8. This was how long it took to freeze and the temperatures. And here is page 2 of my research plan and experimental, as well as the post-lab table. So this was where we were melting the naphthalene into the solution. So this is melted 1.4, that's a minute and 40 seconds. I lied on, no. Yeah. This is part 4 where we were freezing it again. It only started freezing right around, I said 54 here, but I don't think that was correct. I think it was closer to 48. And then when it was frozen at 240 seconds. This is my post-lab table with my work. And then for the Excel curves, this was the curve. So the orange line was the cooling curve for the solution, the mixture, with the freezing point and the light as the light blue dot, and the melting point was right where that arrow is, around 54 degrees. And the blue line is the cooling curve for the solvent for the perodichlorobenzene. The freezing point was again that light blue dot. And the melting point was where that blue arrow is. Yeah.